All right, so this video is on, or giving you more examples of factoring difference of squares problems. Now remember, like we talked about in class, I'm going to predicate it or base it on you guys knowing this equation right here, that a squared minus b squared can be factored to a plus b times a minus b. In other words, I got two terms, they're being subtracted. Each of those terms are perfect squares. That's what it allows me to be able to do this. All right, so let's look at a few examples here. 16x squared minus 25. There's two terms. I know that these two terms are separated by a subtraction. I know the first one is a perfect square, 4x being squared. I know the second one is 5 being squared. So I know that this can factor to 4x plus 5 and 4x minus 5. All right, and that's it. Okay, so let's take a look at this one. What if I have 16x squared minus 9y squared? All right, I see two terms. The first term is 4x, and I'm squaring it. The second term is 3y, and I'm squaring it. So that tells me that I can factor this to 4x plus 3y times 4x minus 3y. Okay, let's take a look at this example. What if we have negative 2 plus 2x squared? Well, the first thing with this, I don't like the way it looks, so I'm going to rewrite this as 2x squared minus 2. In other words, I write it into standard form. First thing that I recognize here is, yeah, it's got two terms, but I also notice that there is a GCF. So I'm going to factor out the GCF of 2, and that leaves me with x squared minus 1. Now, I know that x squared, or I'm looking inside here, I believe that x squared is going to be x times itself and 1 times itself. So this can further factor to 2 times x plus 1 times x minus 1. Yes, I would be expected to factor it as far as I can. But remember, when I factor it, I'm only using this when it's quadratic. In other words, back up here in this 4x plus 3y, I'm not going to try to factor that because it's not quadratic. There's nothing being squared. All right, a few more examples here just to try to give you a bunch of different scenarios. Let's say that I have 8x squared minus 200. All right, the first thing I notice here is I've got a goal number, or sorry, not a goal number. I've got a GCF of 2. I know that 2 goes into both of them, leaving me with 4x squared minus 100 inside. I have a difference of squares inside. How do I know that? 4x squared is really 2x squared, and 100 is really 10 squared. So I know this can factor further to 2 times 2x plus 10 and 2x minus 10. But wait a minute. That doesn't seem like that's right. Maybe I should have pulled something else out. All right? Yes, you could have pulled something else out, but this is also going to be good enough factored form. Or is it? The answer is no. The reason why it's not is because what I should have done originally back here was I should have factored out a 4. So if I pull the 4 out, let's see what's left. I get 2x squared minus 50. Oh, that doesn't work because I don't know 2x squared. So maybe I missed something else there. What if I factor an 8 out? All right. Now, 8, if I factor that out, let's see what I get. I get x squared, and 8 times 25 gives me 200. Ah, that looks a little better. All right, so now this is going to become, this is a difference of squares, x squared and 5 squared. So now this will factor to 8 times x plus 5 times x minus 5. All right, this is the correct factorization. Even though the previous one worked, this is the one that we must factor to. All right? So let's try another scenario now. Let's say for this one, we have 8x cubed. Minus 128x. Well, the one thing that I notice is they both have x, and they both have multiples of 2. All right, so there's definitely going to be a GCF here. I'm going to bet that the GCF is 8x. So let's see. If I pull 8x out of 8x cubed, I'm left with x squared. That worked nicely. If I pull 8x out of 128x, I know 8 goes into 128 16 times. Works out nicely. How do I know it works out nicely? This is x being squared. This is 4 being squared. So I know this can continue to be factored to 8x times x plus 4 times x minus 4. Could I have done a GCF of 2 there? Yes, but it would not have been the simplest factorization. This is the simplest. All right, and the last one here. What if I give you a polynomial like this? 3x to the 4th plus 6x cubed minus 3x squared minus 6x. Well, let's take a look here. Because there's 4 terms, I'm immediately going to think grouping. I find the GCF of the first set, and the GCF there is going to be 3x cubed, and that leaves me with x plus 2. Now I need to factor the second one so that I end up with x plus 2 as a binomial. So I know that there's going to be a GCF of negative 3x there, and that would leave me with x plus 2. All right, so let's see where we're at now. This becomes x plus 2 times 3x cubed minus 3x. Well, I notice in this second parenthesis here, this second binomial, that I have a GCF. I'm going to take that GCF out and throw it all the way back in the front. So it has a GCF of 3x. I still have this x plus 2. And when I pull the 3x out of both those pieces, I'm left with x squared minus 1. X squared minus 1 can still be factored. Remember, I'm looking anytime that we have powers greater than 1. I can factor that, so this is going to factor to 3x times x plus 2, and x squared minus 1 factors to x plus 1 times x minus 1. All right, this is the complete factorization. Hope this helps. Let me know if you have any questions.